Hello, in this series of 7 videos we're sketching the 10 most popular parent functions. In this 5th video we're going to graph the rational function. Sometimes people call it the reciprocal. I've seen it called inverse, but most people think inverse as being something else, but basically we're going to be graphing y equals 1 over x. And this one's kind of interesting in that with our variable is in the denominator. It's the only one of our parent functions where the variable is in the denominator. So again, if we want to make a table of values with x and y, and again we can start off with, say, -3, -2, -1, 0. -3, if we put that in denominator, we're going to get a -1/3. So if we go -3, we're going to get a dot that's very, very close to the x-axis. -2 in the denominator is going to be -1/2. -2, -1/2. -1 in the denominator is just going to be a -1. -1 over 1. And you may be tempted to say, well, 0, if I put 0 in there, it's going to be 0. But this is actually undefined, which means we can't graph it. There is no number y for the number x, for the number 0 and the x. So do not graph 0, 0. That's a big mistake people make. So this one looked like it was going down. What if we were to try some other values, maybe some fractional values, like -1/2? If I plug in -1/2, what's the reciprocal of -1/2? That's -2. So that would be this point right here. How about say 1/3? -1/3 would give us a -3. And so what we'll see is we have a very gentle curve that starts off very close to the x-axis and then comes down very close to the y-axis. On the positive side, we're going to get the exact same pattern. If we plug in, first off, 1, 1 always works. But if we plug in 1/2, if x is 1/2, y is 2. If x is 2, y is 1/2. So we're going to get a similar pattern on the other side. It's going to get very close to the y-axis, and it's going to taper off very close to the x-axis. And these are called asymptotes. So one way of graphing this, you can actually use dotted lines to represent the asymptotes. In this case, the dotted lines are the x-axis and the y-axis, and then the graph gets infinitely close to both asymptotes. The graph of y equals 1 over x looks like this, or more accurately like this.